Hello students, welcome to another video on the channel Maths with ℤ𝕤𝕤. So in today's video we will be solving a question on complex numbers, and this question was given in the IIT Kanpur's advanced sample paper. So this problem is not a very difficult problem, and it's very easy if you think in the right direction. So this problem is based on complex numbers, which is a very horrible chapter for most of the JEE aspirants. Most of the JEE aspirants face problem in this chapter. But believe me, this is not one of them. I will be showing a very amazing and very short method to solve it. But before that, I will be showing a solution that was proposed to me by one of my students. And after seeing the solution, I just felt like I should do a video on this problem, right? Because most of them would be solving in the similar way. So let's get started with the formal reading of the question. And those who want to try it without my supervision, so they can just pause the video right here and go on trying the problem. And if you have solved it, you may check your answer at the end of the problem, at the end of the video. So let's get started with the problem. So as you can see, the question that is given above, right, in the first lining, so that is my question, that is the problem which I will be solving today. And the question that is given below is the homework problem for you all, that is the advanced sample paper question. Both the question are almost similar, just the one part of the problem is changed, the numbers. So let's get started. So before starting with the solutions, tell me, what do you understand from the following given question, right? If the value of z is equal to a plus iota b, then we can proceed the problem with brute force, right? We can just try solving the value of the following expression by putting z equal to a plus iota b, and that's nothing much great about it, just the calculation becomes very lengthy. So that is the first method here that I have given. So don't start reading the solution on your own, let me just guide you through it, that will be very easy. So let us assume that z is equals to a plus b iota, right? After we have assumed this value, we can say that if we just directly solve for the values of omega, let's say omega is the value for this one, the expression that is given to us. So if we solve for omega, we will get that the real part of omega is nothing but 81a minus 108b. As you can see, I will be just marking it down so that you can understand which part I am talking about. So this part I am talking about, as you can see, it is just 81a minus 108b. So this is the real part, right? I have done nothing, just the calculations part I have just shown it here. You may read it on your own, or let me just guide you through it also. So first of all, note down that z is mod of z is equals to root over of a squared plus b squared if we assume that z equal to a plus iota b. Now that is given in the problem that it is equal to 4, right? So may use this information right here that is given to us, so that we can get a help over simplifying the denominator part, right? The denominator is very nasty, so we will just simplify the denominator, and we simplified the denominator and put the values together. So the value of this comes out as a very nice entity. So now finally the expression becomes 81a minus 108b, but believe me, this method is very long and very hard working method. I wouldn't have solved it like this if I had been the student and giving the exam. In exam point of view, I wouldn't have solved it like this. So after this, what we should do is, we have 3 part methods after the following simplification on how to maximize the value of this expression, right? That is a real part of omega. We can maximize it in 3 possible methods. So the first method that you can see is obviously Cauchy-Schwarz method. So most of the advanced aspirants should be familiar, and also the Olympiad aspirants are familiar with it. But let me just go through the review of this method. So I have written down the theory for the following method, that is Cauchy-Schwarz method, and you may understand it from here. So Cauchy-Schwarz method, as the name suggests, it is not a very big method, right? It is just the following inequality that I have written, that is, if there are n real numbers, right? If there are n real numbers such that ai and bi, right? What is ai? It is ai, I have written that ai is equal to a1, a2, a3, a4, all of them up to an. I have just denoted them by the value of ai. And what I have done for bi is that I have written b1, b2, b3, b4, all of them as bi. So if they are real numbers, there is no condition for positive real numbers, it is just the real numbers. So the following inequality holds at that point of time, that is, when we get the product of them in an ordered manner and add them, that is, we multiply with a1 with b1 and a2 with b2, a3 with b3, and so on, so that up to an we multiply bn, and then add all the terms, and that quantity whole squared is always less than or equal to a1 squared plus a2 squared plus a3 squared plus dot 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 up to an squared times b1 squared plus b2 squared plus dot 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 up to bn squared, right? Not a very hectic or difficult thing to remember, just that I have separated the ai one time and I have just separated the bi for the second product, right? So with the help of this formula, what we can do is, in the given question we have the value for maximizing the value of 3a minus 4. We have just simplified the given real part to this expression, right? So we have to just find the maximum value for 3a minus 4b, and 27 is a constant, so there is nothing much changing about 27. So now moving on to the solution, I would suggest giving it a try right now, because you may get familiar with the Cauchy-Schwarz inequality, and it will also be an extra tool to attack the problems in the paper. If you are finally finding some questions that are given on inequality, this is a very handy and useful inequality that you can use. So I hope you have given it a try. Now let me start it with the solution. So I have just written down the following expression, that is, I just took the values of a1 as equal to 3, right? Let me just note it down for you all. So I have taken a1 is equals to 3, and I have taken a2 is equals to minus 4. I also took b1 as a, right? Do not confuse it with a1 or a2, it is just the variable a, and I took b2 as equals to b. Now you can understand that what happened is I just simplified this expression as 3 squared plus 4 squared is equal to 25, and a squared plus b squared, as I have earlier mentioned, that it is just equal to 16, right? So this expression is just equal to 16, and after multiplying it we get it equal to 400. Now here comes the tricky part to this solution. Most of the aspirants here commit a mistake, that is, they think that the value of the expression that we have got is 3a minus 4b whole squared is less than or equal to 400, right? So most of the aspirants here commit a mistake, that is, they write after the following, they write that 3a minus 4b is less than or equal to 20. This is correct, but more accurately, if you, when let's say when the times where that it had been a subjective exam, or let's say you are writing a solution for ISI or CMI. At that time you have to be very cautious about what you are writing. So this is not correct. You may get a negative marks for that as well in the subjective paper. So you have to give a modulus here, right? You must put a modulus in this following expression, because when you remove the modulus, at that time you may say that 3a minus 4b belongs to minus 20 to plus 20, right? This is the range of 3a minus 4b. You cannot say that it is less than or equal to 20 and it goes up to minus of infinity. It has a limited range, right? So that is a very cautious point that you need to take a note about, and that is what I have mentioned it here in the next step of the problem. That is 3a minus 4b is less than or equal to 20. Now obviously the maximum value for the expression right now will be equal to 20, because you can obviously know that, wait a minute, you may obviously know that the positive value is greater, right, than the negative value. So obviously the maximum value of the expression must be equal to 20. Now I'm just clearing up this part so that I get a space for the next solutions also. So now for the next solution, before proceeding to the next solution, the next solution is about vector algebra, right? The method 1b, that is about vector algebra, proposing a solution on vector algebra. See, vector algebra is not always recommended, the use of vector algebra, because vector algebra may lead to a lot of complications in the future. This problem, it is very simple to apply the vector algebra, but in future it may not be so useful, right? So try to remember the method 1a. It is very much useful. This method 1a is very much useful, right? You must remember this method 1a, because this will come up very handy in Olympiads, and also if you are a JEE aspirant or any ISI or CMI aspirants. So it will be very handy for you all. So let's get started with the second solution now. So this is the vector solution. So in the vector solution, as you can see, I have assumed a vector x. What I have done is I have assumed a vector x, that is 3 iota minus 4 j cap. Sorry, no, not 3 iota, it is 3 I cap minus 4 j cap. Sorry. So it is 3 I cap minus 4 j cap, and I have also assumed a vector y, which is equal to a iota, sorry, not a iota, I am just mistaking it, a iota plus, wait a minute, that is a cap, right, a cap, yeah, a cap and plus b j cap, right, it will be plus here. I have just committed a mistake here. So this is 3 I cap minus 4 j cap, and the second vector I have assumed it as a I cap plus b j cap, right. Now what I have done is I have just taken the dot product of the value. What I have done is I have taken the dot product of the value, and as you know that a vector dot b vector, wait a minute, a vector dot b vector is equals to modulus of a vector into modulus of b vector into cos of theta, right. Now this cos theta varies between -1 to +1, right, and therefore if I just take the modulus of this one also, what will I do is, see, this one is a positive quantity, this one is also a positive quantity, but the cos theta might be a negative, might be a positive quantity. So when I take the modulus, I just make this quantity always or partially less than 1, that is cos theta. I have just made that modulus of cos theta is belongs to 0 to 1, right? Now this is very useful, right? Because what I do is, for the maximum value I take it equal to 1. So when I take it equals to 1, the value of the expression would be modulus of x vector into modulus of y vector, right? And we know that modulus of x vector is equal to 5 and the modulus of y vector is equal to 4. So it's a very easy calculation from here, that is 20, right? So it is also giving the same value as the answer. Now for the next part of the solution, that is a solution by geometry, right? We have proposed a coordinate geometry solution, and I prefer that the coordinate geometry solution is a mind opener solution, right? This coordinate geometry solution is a very mind opening solution, because most of the time in JEE there are problems that are asked on coordinate geometry that are much simplified if we can understand the core concept behind it. Just like this problem, it is an algebra problem or complex number problem, but I have just transported the core from algebra to a coordinate geometry and I have just simplified it. So what I did is, we may restate the problem again as we want a line, right? That is 81x minus 108y, that is a real part of omega that we found, is equals to k, such that it is tangent to x squared plus y squared equal to 16, right? That is our motive, because what we want is that the following line, that is this expression that we have found out, that is the real part, it may have infinite number of values or it may have also a limited number of values, but what we want is that it must also satisfy x squared plus y squared equal to 16 condition. Why this is so? Because you know, right, that modulus of z vector that we found, that is equal to 16, and if I take the modulus of z vector equal to modulus of x plus iota y, then it is just equal to 4, and hence we get the following condition, that is x squared plus y squared equal to 16. Also, the following line, when it is tangent to the circle, it will give the maximum value. Why do I say so? You may understand the following by the help of this example. Let's say this is the circle for given to us, and there are infinite number of lines that will be cutting it and parallelly, right? If I just change the following value of k, wait a minute, if I change the value of k, if I change it, there will be infinite number of parallel lines, right? Because the value of the slope doesn't change, it is the intercept value that changes, right? So when it is cutting the circle 2 times, right, either there may be three statements from here, that is, it may cut the circle 2 times, it may not cut the circle, or it may be tangent to the circle. So when the line is cutting it twice, the circle twice, we may get the intercept increasing a bit so that it may become the tangent, and finally when it is a tangent, we may get the maximum value to the slope intercept so that it satisfies both the conditions, right? This you may also have learned in the school as linear optimization or LPP problems. So what I have done here is very simple statement. I have written it here, that if we drop a perpendicular, from h comma k, right, from h comma k, if I drop a perpendicular onto the line ax plus by plus c equal to 0, then the length of the perpendicular is equal to ah plus bk plus c modulus divided by a squared plus b squared. That is what I have done it here also, that I have taken the line to be 81x. As you know that I have taken the line to be 81x minus 108y equal to k. So if I bring the k to the right hand side, or sorry, to the left hand side, then I can get this expression in the form of ax plus by plus c equal to 0, and further I can solve it so that we can get the value of k is equal to 540. Now the value of k here is equal to 540 because we have taken the value of 81x minus 108y, whereas in the previous solutions we took the value of 3a minus 4b. We took the value of 27 as common outside, right? So the maximum value of this expression, that is 3a minus 4b, is equal to 20, and the constant part that is there, that is 27, is always present. So what we have done is we have just multiplied 27 with 20 and we will get the answer as 540. Now I hope you have understood the solutions so far, or should I just revise all the solutions, right? I must revise all the solutions to you all. So starting from the beginning, what I have done is I have just taken a variable z, that is equal to a plus iota b. Then I have taken a value as omega, that is the defined value in the question, right? And I have just simplified the problem or expression to find the real value. So simplifying was the most tough part of the problem. After that, what I have done is I have just used the Cauchy-Schwarz inequality as the method 1, so that we can help out the solution very easily. And what is Cauchy-Schwarz inequality? It is nothing but the following, that is a1 plus b1, a1 b1 plus a2 b2 plus a3 b3 dot 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 up to an bn, when whole squared is always less than or equal to a1 squared plus a2 squared plus a3 squared and so on up to an squared. This is in a bracket multiplied by b1 squared plus b2 squared and up to bn squared, that too also in a bracket. Now this condition, the condition for this is that a1 and b1, or not just a1 b1, it is also about ai and bi, must belong to real. Now after that, what I have done is that I have just simplified the following in the expressions. And the second solution, for the second solution, I assumed a vector x vector as 3i cap minus 4j cap, and I assumed a y vector as ai cap plus bj cap. Then what I have done is I have written that the dot product of x vector and y vector is always less than or equal to modulus of x vector into modulus of y vector. So that gives us a very useful information about the problem, and therefore solving the question is very easy. Now for the third method, what I have done is I have restated the problem in the coordinate geometry. I just assumed that there is a line, that is 81x minus 108y, and I assume that it is equal to k, right? For any value of k, it is equal to k. And now what I know is that the value of x squared minus y squared is always equal to 16. That is, the modulus of z is equal to 4. That is why x squared plus y squared equal to 16. So I used the condition of linear optimization, that when the line is tangent to the circle, it will give the maximum value of the intercept. So that intercept value I got it out as 540 by the help of the length of the perpendicular must be equal to the radius. So that is the solution so far. Now as I have promised that I will be providing a much simpler solution than all of this. So here it is. So what I have done is I have just written down that z vector, or not, sorry, complex number z, right? Complex number z times the conjugate of the complex number z is always equal to modulus of z squared, right? Let me just highlight it down so that you can understand which line I am talking about. So this is the particular thing that I am talking about. From here what I have taken out is that the conjugate of z bar or z bar is equal to 16 divided by z. Now what I did is I assumed here the Euler form of complex numbers, that is z equal to 4 e to the power iota theta, right? This is very handy, that is always use the Euler form when it is about calculations, right? When you are simplifying, always use the Euler form of the complex numbers, because it is very useful and very simplifying is very easy with the complex numbers with the Euler form. So now our problem becomes that omega is equal to this expression, right? That is, I just have taken down 16 common from the second part of the numerator, right? I took 16 common outside, and 16 by z is equal to, this is 16 by z is equal to modulus of z, sorry, not modulus, it is conjugate of z. Now conjugate of z is also equal to 4 e to the power minus iota theta. So what happens is I just took down the values, and it helps a lot because in the simplification, because what I can do is I can just write the value of e to the power iota theta. I can just write down that e to the power iota theta is equals to nothing but cos of theta plus iota sine of theta. Wait a minute. So what I can do is I can write cos theta as e to the cos theta plus iota sine theta. I have just simplified the value of e to the power iota theta, nothing big about it. So after that what I have done is I have just focused on the real part. Now it is very easy to focus on the real part, right? We don't have to calculate the imaginary part as well, because see, what you can do is, this is a very shortcut method, that is 75 into 4, and as 75 is the real part, just multiply the cos theta term with it, and 117 iota, as it is a complex part, multiply with it a complex and get the real value, right? So which on simplification gives us the value as 324 minus 432 sine theta, right? Now what you can do is you can again take out common as 108, and you can solve that the following expression becomes 3 cos theta minus 4 sine theta. Now obviously that is a cos theta plus b sine theta is equal to a squared plus b squared root over, and this is the maximum value of the following expression, right? This is the maximum value of the following expression. So it is very useful if you know this trigonometric optimizations and trigonometric shortcuts. So hence what I can say is that the maximum value of the following expression, that is 3 cos theta, so the maximum value of 3 cos theta minus 4 sin theta is equal to root over of 3 squared plus 4 squared, that is equal to 5. So which on multiplying it will give us the value of the real part, or the maximum value of the real part, equal to 540. So the answer to the today's problem is 540, and I suppose that you will be solving the homework question that I have given, so that you can understand the greatness of the last method that I have shown you, right? Also, I would suggest that you try the method 1 initially, right? I would suggest trying the method 1, then after going to the second method that I have shown, that is this one, using the complex numbers and things like Euler inequality and all that. So that's it for today, and please do like, share and subscribe the channel, and share it with your friends, those who will find it helpful. So thank you. See you guys in next video.